Hi, welcome to Mathematics with Tom. This is Tom, and today we're going to continue looking at conditional probability. Conditional probability, and I've brought in this table that we've used before, and we're going to find a probability, a couple of these. So let's try this. Find the probability of randomly selecting, so I'm going to put that in, the randomly selecting a female given that you're looking at your SUV and minivan drivers. Okay, well, let's remember our formula. Our formula then would say that the probability of selecting a female and then, meaning order matters, or I'm sorry, I wrote that incorrectly already. So the probability of selecting a person that drives an SUV or a minivan, and right after that, selecting a person that is female. So really, we're going to be selecting two people. Selecting two people here is equal to the probability of randomly selecting an SUV or minivan driver times the probability of selecting a female given that the first person selected was an SUV or minivan driver. Okay, so let's go through and let's find each one of these probabilities. So here we go. I'm going to use this orange to start us off. The first one, the probability of an SUV minivan driver and a female is this one right there. It's this 3. So I can say that is 3 out of 50 people equals. Now, the probability of picking an SUV driver, that's probably another color like this. Well, an SUV or minivan driver in general, there's 8 of them. So, and there's 50 total. Again, I'm using this 50 over here. So, I could say that the next one is 8 out of 50. And I wouldn't reduce my fractions yet. I'd wait. That's always often a last step in probability. Times the probability of a female given that the person was probably drawing a female given that an SUV or minivan driver person, that's a mouthful, has already been selected. So to solve this, we're going to use a little bit of algebra, and we're going to multiply both sides by the 50 over 8. Remember, that's the primary law of algebra, is if you do something to one side, that's fine. Just do the exact same thing to the other side. Now, we do that and a couple things happen, some helpful things. First off, I'm left with the right side being my answer. The probability of a female given an SUV or minivan driver was already selected. But watch what happens on the left-hand side. The 50s cancel. The 50s cancel. And now I can write my answer. I can say that 3 out of 8 is the probability of selecting a female given that an SUV or minivan driver has been selected. Now, let's do this. I want to look more closely here. And what I want to show you is look at this. This 3 out of 8. Well, the first thing this problem did is it started with restrict yourself. The condition is the restriction of SUV or minivan, folks. So that's this pink column here. And notice that there are 8 people in that category. Now, then it says the probability of a female, well, that's this 3 right there. And so conditional probability, when you're looking at them, if you're using a table, you have the ability to actually just watch the restriction being created. So if you're uncomfortable with that, then you can always go back to the formula, or if you're not comfortable with the formula, you can read the words and see what they're saying. So now let's change the problem. Let's change the problem ever so slightly. What I'd like to do now is find, whoops, is I'd like to find the probability of randomly selecting an SUV or minivan driver given that the person was first a female was selected. So wait a minute. Well, all I did was switch the order. Are they the same? That might be an initial reaction. Well, let's find out. So this time I'm going to go with just the words here. So I'm going to grab a highlighter here. Let's change color. This is probably a green issue, if there's ever has been a green issue. Now this says start by looking at female. So a female had to be selected. Well, that meant that the first person had to come somewhere out of this group of people right here. Okay, that was the first thing that had to happen. The next thing that had to happen then is that from those people, that we had to select an SUV or minivan driver. Well, that is this 3 right here. So the 3 gets used again, but notice that the denominator is different. So now I could say that the probability of an SUV or minivan person, given that the first person is female, is 3 out of 30, which reduces down to 1/10. Now, here's the interesting piece. What did we find? We found that the probability of selecting a female, given that the first person was an SUV or minivan driver, is not equal to the probability of first selecting an SUV or minivan driver, given that the first person selected is female. When these events are not equal, this is the mathematical way of saying, this is mathematical way of showing events are independent. I'm sorry, no, independent, goodness. Are dependent. Are dependent. So the order in which they happen makes a difference. So you might be like, well, when would that not be the case? So, well, what about rolling die? Say you have roll a green die. And a yellow die. Now, let's do this. Let's do something interesting. Maybe I wanted a green 4, call it G4, and I wanted a 3 on the yellow, so we'll call that a Y3. Now, think about this. If I roll the green die first, and I get a 4, what's the probability that I get a 3 on the yellow? Well, that would be 1 out of 6. Okay, what if I change that now? What if I change that to, what's the probability that the yellow die lands with a 3? And then that the green die gives me a 4. Well, what happens with yellow in no way affects with what happens on the green. So those probabilities are equal. And so when this is the case, this is the mathematical way, the mathematical expression of independent events. Independent events. And the final step is this. When that happens, we say then the probability of A, and B becomes the probability of A times the probability of B. And that is when, this restriction, when the probability of B given A is equal to the probability of A given B. Or you could just say that the probability of B given A equals the probability of B, like that. And that is how you find conditional probabilities, and it shows what the difference is between a dependent and independent event is. Hope that